Okay, guys, let's talk about calculating slope. The first part of this is review, okay? Slope is the rate of change. So if I'm writing, then you should also be writing. It's the rate of change. It tells us how steep a linear function is when it is graphed, and it is represented by the letter m. You should definitely know this by now. I trust that you do. Let's see if I can scroll down here. Here we go. Okay, it's represented by, it means change in y over change in x. This the little delta here, this little triangle means change in, and it is the ratio, that means it's a fraction. Remember that ratio is a fraction of a line's vertical change up and down to its horizontal change, left to right. And there are 4 types of slope, as you remember. The first is puff, puff, positive, slope dude says. Nice, negative. Now let me show you puff, puff, positive. Nice, negative. 0 fun. That's your y equals line. And undefined. That's your x equals line. Now we are going to calculate slope. Calculating slope. So we're going to derive the slope formula by starting with the point slope formula. This is review for you. This should look familiar to you. So we are going to solve for m. We're going to do a literal equation here. I see multiplication. This m is multiplied by this x minus x1. What I do on the left, I do on the right. Okay? Anything divided by itself is 1, and we're left with y minus y1 over x minus x1 equals m. And this is the slope formula. Let's take a look at some problems. So this is the slope formula, and you do need to have it memorized. It will not be given to you on your SOL, where x1, y1, and x2, y2 are ordered pairs. You're going to be given 2 ordered pairs. And you can see that I have given you a bit.ly here. If you are a person who likes to play along with Desmos, you can do that on your own. You can take a look at that. So I'm going to do the first one for you, and then I'd like you to try the next 2 on your own. Of course, I'm also going to do them, but I want you to pause the video and give them a try. Okay, so we're always going to do the same thing. We're going to start by labeling the points. So x1, y1. This is going to be x1, y1, and x2, y2. You're going to write the slope formula. M equals change in y over change in x. And then all you need to do is substitute in what you have. So let's start with y2 is 6 minus, because the slope formula says minus, y1, which is 2. It's right here. See, we labeled it. Over blue x2, 2 minus, because the slope formula says minus, negative 4. It's right here, right? 6 minus 2 is 4, and 2 minus a negative 4 is 6, and the slope is 2 over 3. Okay, let's try number 2. I'm going to want you to pause the video. I want you to start by writing the slope formula. M equals change in y over change in x, and give it a try. Substitute it in. Did you try it? I hope that you did. We're going to start by labeling these points. Let's start by labeling the points. x1, y1, x2, y2. And everywhere that I see x2, I'm going to use negative 1 minus 5 over 6 minus 3. And every year someone always asks, does this have to be 2? It doesn't. What has to, these must come from the same ordered pair. So you can see that -1 and 6 are together, and here they are together, and these must come from the same ordered pair. And they do. 3 and 5 is the point you're given here. So you can see that's on the bottom, 3, 5, and 6, -1. Let's reduce this fraction. -6 over 3 is equal to -2. So the slope is -2. All right. Try number 3 on your own. Pause the video. Did you try it? We're going to start by labeling the points x1, y1, x2, y2, and writing the formula m equals change in y over change in x. Oops. Everywhere I see y2, I'm going to use 23. Everywhere I see y1, 14. Everywhere I see x2, 1. And everywhere I see x1, 5. 23 minus 14 is 9 over 4. And that can't be reduced, so that's the slope. And now we have some special cases. And we always have some special cases. Maybe you're thinking ahead and you can guess. Maybe you think, I've heard special cases before. Hohenbachs, Hohenbachs. So let's start by labeling the points. Okay, here we have x1, y1, and x2, y2. What do you notice? Do you notice that x is equal to 3 for both ordered pairs? Do you wonder what that's going to do when you calculate the slope? So I'm asking what kind of line of this, and what kind of line is this? This is your Vux line. And you know this because x is the same. Now look at this crazy thing that happens when you calculate the slope. What do you think is going to happen? Well, you have, let's do m equals y2 minus y1 over x2 minus x1. Everywhere that we see y2, we're going to use -1 minus 7 over 3 minus 3. Oh no. Now here is the thing about algebra. Algebra 1, algebra 2. You cannot have a 0 in the denominator. If you have a number on top and a 0 in the denominator, that is a no. That is a vertical line with an undefined slope. So m is undefined. Well, I bet that you can guess using pattern recognition if that was your Vux line, what the other special case is about to be, but let's do it anyways. x2, x1, y1, x2, y2. What do you notice? What do you notice? I notice that both have y equal to -6. What do I wonder? Well, I wonder what the slope of this line is going to be. This is your Hoy line. So let's calculate the slope. Let's calculate the slope. Equals y2 minus y1 over x2 minus x1. Everywhere I see x2, I'm going to use -6. Everywhere I see y1, I'm going to use -6 because it's the same. And on the bottom, 1 minus 3. Well, 6 minus a -6 is 0 over -2. And anywhere you have a 0 on the top and a number on the bottom, that is okay. And that is your horizontal line with a 0 slope. m is equal to 0. Okay, work through your classwork. It's on GoFormative. Get your homework done. Hopefully this was useful, and I'll see you soon. Thanks.